New lecture manual, section 4.1, antiderivatives. Now let us suppose that f of x is 2x. If f is the derivative of some function cap f, then cap f would equal x squared. So f is the antiderivative of little f. So this is a derivative, and that came from this function. But the question is, could cap f have also been x squared plus 2 or x squared minus 7 or anything with x squared and then a constant added or subtracted? Yes. Therefore, we have to say that we have a general antiderivative. And the general antiderivative of f of x is going to be cap f, notice the notation change, which is x squared plus some constant c, where c is a constant of integration. I like to call it the c of frustration because at the beginning, students forget to add the plus c and lose lots of points. New sign, squiggly s. We'll talk about that more. The integral of f of x dx is read as, integration sign, the antiderivative of f with respect to x. And we call this an indefinite integral. Now it has parts. This part is the integrand, and dx identifies the variable of integration. Now I can look at some notation. You notice up here we had little f whose antiderivative was cap f. I can also do the antiderivative of cap f prime of x dx would give me cap f of x plus c. So integration is the inverse of differentiation. I could also look at my notation. The integral of little f prime of x dx would be little f of x plus c. So the notation is going to matter. Pay attention to what's given to you. And if I take the derivative of an integral, I get the integrand. Let me say that again. Take the derivative of an integral, I get the integrand. Or the derivative of the antiderivative is the integrand. Okay? Why would that be? Because the antiderivative of f, little f, would be cap f plus c. And when you take the derivative of cap f plus c, you get the derivative of cap f, and the derivative of c is 0. So our basic integration rules. It says see the big gray box on page 250. So you need to do that. The most important part is if I have a constant multiplied by a function, let's pull that constant out and integrate the remaining function. Never pull out a variable. And so to do the antiderivative, right now there's a lot of antiderivative things we're going to do, but this one right now we're going to look at the power rule. So how did this get here? This got here by subtracting 1 from the antiderivative function. So to get to the antiderivative, we're going to add 1 and divide by the new exponent, plus c. So we're going to evaluate the indefinite integrals. Here we go. So remember, x squared is a derivative. Remember our differential form you just learned about. dy would be x squared dx. So y is the integral of x squared dx, which is add 1 to the exponent and divide by the new exponent. So 1/3 x cubed plus c. Or you could write this as x to the third over 3 plus your constant c. All right, what about this one? We do not have a product rule yet. So right now, all you know how to do is to rewrite that. And here we go. Add 1 to the exponent, so that's going to give me x to the fourth, divide by the new exponent, plus 3x to the, add 1, squared, divide by the new exponent, plus your constant c. So we're first of all going to rewrite it, and now we're going to have to add 1 to some fractions, okay? So adding 1 to 1/2 gives me 3/2, and dividing by 3/2, plus 1/2 times add 1 to negative 1/2, that gives me 1/2, divide by the 1/2. Now you would never give it to me like that. So let's do a little bit of algebra. Dividing by 3/2 is times 2/3. Dividing by 1/2 is times 2/1. And now you can see easily how we can simplify that. And you can write this answer like this, or you can write it like this. Again, if we take that x cubed and we simplify it to x squared times x, where the x comes out, that would be in absolute value bars, because we do not know if x is standing for a positive or a negative, so we'd have to make it positive, put the bars on it. Tell me about this one. What do you think that answer should be with respect to t? So your variable needs to be a t. And this technically, if we think about it, is 1 dt, which is t to the 0. So we're going to add 1, divide by the new exponent. Here's what's really neat with all of these. Once you have it, you can take the derivative of it and see if you get the integrand, which you should. If you want to write those down, you can take a minute and do that. If you want to write this information down, you can take a minute to do that. Write these examples down. Okay, let us remember what is inside of here in the integrand. That is a derivative. What is cosine the derivative of? It is the derivative of sine. What is sine the derivative of? Oh, it's not the derivative. Negative sine is the derivative, so we have to bring the negative cosine of x plus c. Again, take the derivative of cosine is negative sine of x times that negative. How can I think about this one here? Well, maybe rewriting the integrand a little bit. I can think of this as 1 over the cosine of x times the sine x over cosine of x dx. 1 over cosine is secant. Sine over cosine is tangent. Oh, what is secant x tangent x the derivative of? It is the derivative of secant of x. Look at that. 1 over sine squared x. That is cosecant squared. What function has a derivative of cosecant squared? Well, nothing has a derivative of cosecant squared but negative cosecant squared. So I could multiply by a negative inside and out. That's just -1. Now, negative cosecant squared is a derivative. It is a derivative of cotangent. Again, all of these plus c. Let's not forget your derivative rules. And the last one of these, what can I do? We can certainly bring the 3 out. What also can we do? Sine is not a derivative, negative sine is. So I can multiply inside and out by negative. And now I know that negative sine, the integral of negative sine of x is cosine of x. In other words, the derivative of cosine is negative sine. I have what I need. There's your answer. There you go for some trig problems. Now we're going to look at antidifferentiation with an initial condition. So find the equation for y at the point 3, 2 if dy dx is equal to 2 times x minus 1. Now let us remember that would mean we're looking at this. And if dy is, distribute the 2, 2x minus 2 dx, then y is, well, the antiderivative of 2x is x squared. The antiderivative of minus 2 is negative 2x plus my constant c. Well, I'm going to do that. I'm going to get that. Notice I could bring the 2 out, and antidifferentiating, this term would be x squared over 2 minus x plus my constant c. So my plus c has to happen here. I can simplify this, but here's what's really neat. This is my general antiderivative, but I have an x and a y. So I can substitute for my x and my y, find that constant of integration, and now write the entire function. Again, what can I do to make sure I'm right? Take the derivative of this and see if you end up with that. And you should. Okay, pause and write down this example. Okay, let me explain the whole problem, and then you can write down the example. Here we go. Find the particular solution. So we're going to antidifferentiate this. and I have an initial condition when x is 2, y is 4. So the first step is write my integral. All the notation is there. Anti-differentiate each step. Add 1. Divide by the new exponent. The 3's cancel. This becomes x plus my constant c. F of 2 equals 4 means the point 24. I'm going to substitute 2 for x, 4 for y. My constant of integration is -2. And there is my function. There we go. All right, pause and write all this down. Again, let me explain the whole problem before you write it down. I'm going to integrate the second derivative and get the first derivative, and I have an initial condition on the first derivative. Then I'm going to integrate the first derivative and get the function, and I have an initial condition on that. Here we go. F prime of x is the integral or the antiderivative of f double prime of x dx. The second derivative is 2x. Anti-differentiating that gives me f prime is x squared plus c. I know that f prime of 2 is 1, so I'm going to substitute the 0.21 in and get my constant. And here is my f prime. Now I need to anti-differentiate again to get f, but here's what's important. F is the antiderivative of f prime. I'm going to substitute in what my f prime is, and term by term, you can see that's going to be x cubed over 3 minus 3x plus. Notice I am not using a c here because c was used over here. So make it a different letter. Okay. And again, I have my initial condition. When x is 0, y is 4. Substitute in, and there we go. You can write it like this, or you can write it like that. Again, you may write down those notes. Your TPs are 9, 13, 17, and 21.